My name's Jen Schmidt. I work at the University of Alaska Anchorage at ISER, which is a Institute for Social and Economic Research. And I've been working with Ziel on this project. This project kind of originated because I was part of an Anchorage Climate Action Plan, and I was working with the Urban Forestry Group, and it was identified that there was a need to better understand the wildfire hazards around the Anchorage area. Their Community Wildfire Protection Plan is from 2008. And so very much out of date. And so I wrote a proposal to the National Science Foundation. And part of that proposal was to assess wildfire hazards and risks in Anchorage and Fairbanks, Alaska, and also Whitehorse, Yukon. And so this has provided local information to make local decisions, but it's also kind of expanded to the state of Alaska. And Zeke, I'll turn it over to you.
Okay. I'm Robert or Zeke Ziel, as Jen mentioned. I've been a fire analyst for nearly 40 years, dating back to when I was trying to calibrate fire danger to fire occurrence in Michigan's Lower Peninsula. I came to Dr. Schmidt's project while I was working for the Alaska Fire Science Consortium in 2019, and have continued to help even after departing the university in 2021. I've used burn probability analysis in both Alaska and Michigan, but have really come to appreciate the direct utility of land cover information in hazard and risk assessment. Many of you are probably familiar with the quantitative wildfire risk assessment process, the QWRA. It's used for regional risk assessment portals and the interagency fuel treatment decision support system. The image on this left side here is the risk to potential structures layer from the Northeast Midwest Wildfire Risk Portal, one of the many portals covering much of the United States. On the right is the same area with a different process for identifying the relative likelihood of potential impact called wildfire exposure. Admittedly, there's been high-level criticism of the exposure assessment process among those conducting QWRA. To begin our presentation, I ask only that you join me in comparing these two products, recognizing that they were produced very differently. And so I'm hoping that you all can see the laser pointer here. But I'll first point you to this area here of elevated or red-colored the sort of curvilinear feature. And you'll notice that the same sort of curvilinear feature exists over here. You'll notice this area of intense red colors here, just west of this lake. Here's the same lake, and just west of it here, you see the same area here. And as you go down here, you can see this is matched by this one, and this area here is matched over here. So overall, you can see that they are telling very much the same story. And so what I would like to do is to, with that review, begin sort of an explanation of the exposure process, the data that we used, and the results that we've generated. So our NSF study of the Arctic urban risk and adaptation focused on three far north communities. And the one we're looking at here is the Fairbanks North Star Borough in Alaska. Using a collection of land classifications from historic Landsat data funded by the NASA Arctic Boreal Vulnerability Experiment, we were able to look at 31 years of vegetation change from 1984 to 2014. Though this classification is general, and you can see there's only 15 classes there, the resolution is good at 30 meters. This most recent iteration from 2014 is overlaid with both 10 years of prior burn scars information on the left and 10 years of subsequent recent fire history on the right. We examined both closely to gain understanding of first revegetation and succession over the 31-year period, and second, to reinforce what vegetation types burn more readily and which burn less so. These understandings are important to better representing how fire changes the landscape and how to assert the durability of that change over time. So exposure assessment, as developed and described by Dr. Jennifer Beverly from the University of Alberta and others in her group, is really a simple and straightforward process. Though she established a process that used fuel types translated into hazard ratings, we adapted the process by asserting that hazard can be derived directly from the vegetation classes, making the process more universal and removing an unnecessary layer of subjectivity from the intermediate selection of fuel types and fuel models. The translation of vegetation classes into discrete hazard ratings, scaled for further application, is key to the process and requires judgment and expertise. I'll show later how we validated the relationship we built. We had to adapt Beverly's three-layer approach for hazard rating. She used a finer and finer effective resolutions to produce different scales, but our resolution of data resolution at 30 meters was not adequate to implement her process directly. Instead, we developed a scaled hazard rating that recognizes intermediate hazards from short-range spotting and surface fire behavior. Once the hazard classification is established, exposure, as represented here, is simply a measure of the average hazard level in the area surrounding individual locations. Our methodology identifies two circular averaging neighborhoods, one with a 500-meter radius, about a third of a mile, to represent the reach of long-range spotting and crown fire potential, as well as to account for large fire growth. And another averaging circle with a 100-meter radius, the length maybe of a football field, to be used in the vicinity of the wildland-urban interface to account for the more frequent and nearby human ignitions found there. Our first step was to assert the potential fire behavior for each vegetation class without any assumption about wind and weather, fuel moisture, or terrain. We're not really trying with our process to predict where fires will occur or how a particular fire will grow. Rather, we're just trying to establish where fire in the landscape would be more or less problematic. Locations with potential for long-range spotting were distinguished from those that produced lesser spotting and those that had potential principally from surface fire. Many of the early community wildfire protection plans, as the one Jen mentioned, are based their exposure and risk assessments on hazard ratings like these, based only on what is at a given location. However, note the nearly universal yellow color, the very high hazard as it is, in the larger subsequent fire scores from 2014 to 23, suggesting that it's perhaps a good indicator of subsequent burned area potential. Once the potential fire hazard has been asserted, both the 500 and 100 meter scaled hazard ratings are assigned, as shown here in the modified hazard ratings. And let's see if I can use the laser pointer here. These, you can see that we produced a set of scaled hazard ratings for our process. Note that the hazard ratings for the smaller 100 meter are higher than for the larger 500 meter circle. And again, that's largely to account for the fact that in areas like the WUI, that there are more fires and they occur closer to where the values of concern are. Beverly's published method used a binary approach to assigning hazard. Either it was a hazard or not, and that as the evaluation circle got smaller, she added more fuel types to produce that. So there are different approaches, but they generally are trying to address the same things. You can see that what happens when they're added is related to how the difference in hazard ratings that we offered. The final step in all this is to produce the exposure rating over the entire area of interest. We use a circular focal statistic as implemented in ArcGIS Pro for both 100 meter and 500 meter assessments to produce exposure, average hazard ratings for each location. Within the WUI areas, we compare the 100-meter and 500-meter exposure estimates and take the maximum value of the two as the exposure estimate at that location. Outside the WUI area, we simply use the 500-meter exposure estimates. Similar to exposure in the QWRA process, exposure here is intended as a relative measure for the likelihood of significant to substantial wildfire impact at a given location. Again, look at the subsequent large burn scar outlines showing primarily the cream-colored extreme exposure estimates, suggesting again that exposure as a useful indicator of potential area burned. Our Fairbanks study area has ample information about where and when wildfires have burned over more than 70 years. In this case, we've evaluated the 2014 instance of hazard ratings using a decade of subsequent burn scars to evaluate the hazard rating distribution within our burned areas. On the left, the table shows that you can see the area burned in the 10 years, 2014 to 2023, following the 2014 above vegetation classification, burned predominantly in the very high hazard. In fact, 81% of the burned area in that decade was in the very high hazard class. And we were able to discern that the frequency, can I say likelihood, of burning in each hazard class declined from the peak of 7% in the very high class to a low of 0.3% of the area burned in the very low class, sort of validating our scaled hazard approach. In the table on the right, you can see the additional utility that exposure ranking provides over the hazard rating itself. If you look in each hazard class across the bottom, you notice these are the hazard classes across the bottom. And in each hazard class, we differentiated the area burned versus the area unburned by the exposure rating. And you can notice in each case, the exposure ratings clearly differentiated area burned from area not burned, especially in the lower and higher class. It really is additionally helpful in identifying where we feel that the potential for area burning is more likely. The annual area burned, shown with blue bars in the graph on the left, is extremely variable on a year-to-year basis in Alaska. It's one of the real conundrums we face, is that you don't really have any idea going into the season whether you're going to have a great deal of area burned in that season or almost none at all. It really is highly variable. But when depicting area burn trends with a 10-year moving sum over that same period, the orange line, as you see here, that when you have these highly exceptional areas of years with burned area, that the effect of decadal averaging tends to extend those out that 10-year period, and you see these periodic peaks. And you also notice that these peaks are growing, as well as the sort of inter peak period, those are growing as well. And it really suggests that that decadal sum rather than annual sums is helpful in our ability to predict or understand what's coming perhaps in the future, especially considering climate change. You know, as seasonal severity rises to extreme levels based on severe drought, you know, that can dry up wetlands, cure herbaceous fuels, lower woody fuel moistures, the flammability hazard can change dramatically, especially for some of the intermediate hazards. In fact, the decade of fire activity and area burned from 2004 to 2013 included the record burned area in 2004 for Alaska, influenced by extreme seasonal drought for much of the eastern and central interior that year, as you can see on the right image. The graph on the left shows a different distribution and likelihood of burning in each of the 5 hazard classes. All are much higher than the earlier slide I showed when I showed a more seasonal flammability conditions where there was no year with severe drought events comparable to 2004. Notice here that not 7%, but 25% of the highest class burned in that decade. And that further, burned area frequency is elevated for all 5 classes. Clearly, some of this increase in the very low class is an unburned inclusions within the burned area perimeters, the very low category of water and barren, that those burned areas were clearly unburned inclusions in those perimeters. But the low and the moderate hazard classes showed significantly additional burning. And when you look at the types in there, the herbaceous, the shrubs, the tussock tundra, and the fens, that those drought conditions really do change the flammability in those types, and perhaps even make it necessary or worth considering adding values, hazard values, and then redoing an exposure rating specifically for those kinds of situations and scenarios. So overall, we learned a lot in the process, and we are still working on translating this into risk information as we go forward for these three communities. But we're really taking it much farther, and for that, I'll turn it back to Jen.
Yeah, so now we go on to kind of this statewide assessment that we've done. And, as I mentioned, this really has been driven by our stakeholders. We started off with the Anchorage and Fairbanks area, and then the Division of Forestry here in the state of Alaska saw these maps that we were making, our exposure maps for the areas, and they reached out to myself and Zeke and asked, hey, can you do this at the statewide level? Because we really don't have a lot of good information for making plans as far as fuel mitigation activities. We need something that's fine scale enough to look around communities and say, where do we want to put in fuel treatments, given the funding that's now coming towards these activities. And one of the problems with the ABoVE data is, it is older. It stops at 2014. The LANDFIRE data, the most recent version that we used was the LANDFIRE EBT layer. That is from 2020. So we have to do less modeling of vegetation succession after wildfires. But the other large thing is communities here, by the Chugach Mountains in the Copper River Valley, they wanted to do CWPP plans, and there was no information for them. So fortunately, LANDFIRE does fill in a lot of areas in Alaska that don't have any, including the whole southeast. One of the other things that LANDFIRE has that ABoVE doesn't have is this hemlock category. So there's only one evergreen category in the ABoVE. In our study areas, we're able to pull in supplementary vegetation information and kind of put in a hemlock layer. But we've asked NASA to do that in their process of creating the ABoVE layers, and it's too difficult. But they are, however, going to expand the coverage for the state of Alaska and release a new layer later this year, which we will use our rapid exposure approach to create another layer for our stakeholders. Looking at these two images, the LANDFIRE on the left, you'll see the LANDFIRE does capture the tundra quite nicely. I think a little bit better than, say, what the ABoVE does. The ABoVE has a lot of grasses up on the tundra, so that was interesting. Looking at it, there's a lot of tall shrubs within the interior here of Alaska. You're kind of seeing more orange, and especially down towards the southwest here above a giant lake called Lake Iliamna. So there definitely are some vegetation differences. And what we did is there's 128 different EBT classes in the LANDFIRE data, and we reclassified them down into these similar ABoVE categories. And then we use the hazardous fuels scores that Zeke showed to make a hazardous fuels layer. So here's the hazardous fuels layer based on those vegetation classes. And you'll notice that there's not quite as much variation as what you saw in the vegetation layers. And that's partially, because you're going down from 15, 16 different classes into 5. And some of the vegetation layers have similar hazardous fuels values. Looking at that, the big differences that I can see, are right about here. It seems like pointer is working. In the LANDFIRE, there are lower values than what you see over here in the ABoVE data. You'll also see in the ABoVE here a lot of lower values here in the interior. And this is partially due to our vegetation model and trying to put wildfires on the landscape since 2014. The LANDFIRE, has wildfire scars going up to 2020. So we have to model fewer years. And it really does capture the vegetation succession, I believe, a little bit better that comes in after a wildfire. Things are growing back faster than what our vegetation model is doing. So, there are some differences between the two layers, but to better kind of examine what these differences look like, we subtracted the two. So we took our hazardous fuels from the above and we subtracted the hazardous fuels from the LANDFIRE. And so the green values indicate where the above has higher hazardous fuels, and the brown indicates where the LANDFIRE has higher hazardous fuels. And so you'll see that some areas do pop out. Again, this area kind of pops out right here. And this is because there's more woodland in the above data than the LANDFIRE. The LANDFIRE has tall shrubs, which has a lower hazardous fuels score. You can't see it quite as well, but down here there is more green because of the above data only having that one evergreen category. Where you're seeing these kind of dark patches here, this is due to the succession model and LANDFIRE capturing the vegetation that's growing back in these wildfire scars, therefore giving it a hazardous fuels score where there's a lot of sparsely vegetated areas here because of the vegetation model that we used in the above data to create these. So these are fires, like around 2013 to 2016 that are popping out. And so overall, this is kind of, what the differences look like. Here is what the wildfire exposure looks like. Well, one of the things that we did to both layers is when we included the wildfire scars, we actually incorporated the Monitoring Trends Burn Severity database. I didn't like how artificial the wildfire scars looked. We all know that there are these unburned inclusions, with Zeke mentioned. And so in areas where there was no burning based on the Monitoring Trends Burn Severity, we just left the vegetation be as it was. And so looking at these two maps, you can see, yay, we have expanded coverage with the LANDFIRE data. Again, in this area, the LANDFIRE has lower hazardous or lower exposure because of that inclusion of shrubs versus woodland over here. Woodland had a value of 100, highly flammable. Again, you'll see a bit more in here. There's less wildfire exposure on the above side, and that's because of these older burns. But also in general, the LANDFIRE tends to capture more forest categories, slightly more evergreen categories and woodland categories than what the above does. The above slightly has more shrubs, which have overall a lower flammability. And just like for the hazardous fuels, for the exposure, we subtracted the differences between the two to look at the two different layers. And one thing is you might see a lot of color on here. Again, the green indicates the above is higher and the brown indicates the LANDFIRE is higher. But overall, they're really not all that different in the grand scheme of things. 70% of the differences are between -10 and +10, and 90% are between +20 and -20. When you look at the mean of the differences, it's almost right around 0. So it's not highly skewed one way towards above or, towards LANDFIRE. Overall, it's pretty impressive how similar they are. That being said, there are local variations, like the North Slope. LANDFIRE tends to be a little bit, have higher exposure values on the North Slope. And again, here you can really see the green pop for the above. So the above is much higher because you don't have that inclusion of the hemlock. But, overall, I would say that it's a very good product. And, as land managers, they're going to be the ones that are most familiar with their areas. And, they can decide which one seems to better capture their area. And one of the things, about this is it's easy to scale it up. You can use it at a local level, say the Anchorage municipality here. You could use it at a statewide level. I had Yukon reach out to me, and Yukon asked me to make a wildfire exposure map for their area. We've actually developed an ArcGIS Pro tool where you just have to put in, your vegetation layer, a reclassification table, and then, your a buildings layer, because we did that buffering around values, and it'll spit out your hazardous fuel layers at the different scales, and it'll spit out your exposure layer for you. So easy to produce, easy to update. You're looking at this here. This is probably our 5th color version. There was a lot of back and forth with communities as far as how do we make this easy to understand. When I first presented it to the communities here in Anchorage, they said, no, you have to find a hemlock layer to include in there. This exposure is way too high in our area. We don't believe it. So we did that where we could include the hemlock. The color scheme, that didn't go over so well. So we went through rounds of different color schemes. The other thing too is initially we used 0 to 10, 10 to 20, 20 to 30. And people were, well, what does a score of 30 mean? Well, really, we need to change it. So now we just have categories of very low, low, moderate, high, and very high. So definitely when I show this to people around the communities, I've had probably 30 presentations, they get it. They understand the flow from vegetation to hazardous fuels to what I'm seeing. And when I explain to them that this incorporates embers, so it's not just your property, it's your neighbor's property, they get it. And overall, like Zeke mentioned, there's fewer assumptions and assertions. The biggest one being you got to reclassify your vegetation into hazardous fuels. That's our biggest assumptions, but you don't have to make decisions about wind direction, wind speed, fuel moistures, things like that. And, lastly, as I mentioned, it's good for both temporal and spatial in comparison. So we can look over time and see how things have changed, which is important for communities looking for development, looking at how development is influencing their wildfire exposure scores and ultimately risk. And you can also look both locally and at the statewide or even cross-border level here. We can compare Alaska and Canada.
Randy, I have one. I'm pretty new to Alaska, as you can tell by my accent, as well as to how these kinds of products are used. Zeke or Jen, can you sort of describe how, say, Anchorage or Whitehorse or somebody, what would they do with this information?
Sure. Well, in the Anchorage area, the Anchorage municipality, which is kind of like, your form of counties down below, they have actually put a link to it on their Office of Emergency Management webpage where they have their wildfire mitigation outreach activities with residents. And so they're encouraging people to look at their wildfire exposure scores. And typically if you have, a score of 60 or above, which is high or very high, do a FireWise assessment, come in, they'll do a FireWise assessment of your property. So I've developed web apps where all 3 of the communities can go in and take a look at what, what the area looks like, type in their address, and see what your score is. The other thing is Zeke and I have used this to develop a wildland urban interface for Anchorage. And the rules from down below do not work so well up here in Alaska to classify a wildland urban interface. So we're trying to reinvent the wheel, something specifically that works for us. And this exposure definitely plays into that. So they have formally accepted a new WUI for the Anchorage area. And they have used this map to secure funding to update the community wildfire protection plan. So they put in the maps and identified needs. And so it will be used, it was used to get the funding and it will be used going forward to do their CWPP plan and mitigation work. And the state is putting it on their website too, so fire managers have access to it and can use it to plan field treatments and for CWPPs across the state.
I was curious, Jen, maybe a tag-on question, and for you, Zeke, as well. If we assume that, your maps are perfect, let's just assume that for the moment, and maybe a fuels map with, the fire behavior fuel models, the 13 or the 40 or whatever you may have in Alaska, let's assume the moment they're perfect. How would you distinguish how you might use fuels data versus exposure? Could you discuss that as a non-fire person? I would appreciate some clarification on how you might use the different products. And again, I know there's accuracy questions, running through all that, but
I think one of the things that we really came to appreciate about this was that going directly from vegetation to hazard left out that step, that subjective step of converting vegetation classes into fuel types or fuel models. When you actually want to make fire behavior predictions, spatial fire growth predictions for individual fires, say that there's no doubt that the fuel modeling is a necessary part of that process. It's a major input to the fire spread models.
Zeke and I have talked about how the hazardous fuels can be very useful for looking at fuel treatments and the longevity of fuel treatments. I've done some, preliminary work with that, because the hazardous fuels, you don't have that focal statistics going on. So you're looking at a cell, that's what's in the cell. So I'm kind of encouraging people to look at that when they're also trying to plan whether fuel treatments need to go in, need to be revisited, things like that.
A similar question to one I had earlier in the Q&A. Jen, is that Queen?
Wow, someone got it right. It is Queen. Congratulations. I need my backup performance here.
Yeah, can I make a question?
Yes, please. Hello, Ramon.
Yeah, good afternoon. Bon, here in Spain is the night now. I just want to know how I can do for make a fuel vegetation for Merida, Venezuela. I working with a college and I beginning to working with the model, the Rottenberg, okay? So what I want is make a comparison between Rottenberg and the vegetation that we have in the Andes in the Venezuela. Can I do this comparison or you consider that we can make something different? I don't know if you understand my question.
So my understanding is that you want to make a comparison between the vegetation type and the fuel models that the Rothermel model is expecting. Is
Yes.
correct? It is an interesting problem, and one that oftentimes is edited substantially from initial assumptions, and so it is a valuable one to consider. And so I think it's an important thing to actually try to do, that the layers both exist in the US anyway. For CONUS, LANDFIRE produces both vegetation layers and fuel type layers. And so you could make that kind of comparison to see. But in addition to that, I think recognizing that as the situation changes, as the season severity becomes worse, as the fuels become more flammable, a different fuel type might be the appropriate choice for a given vegetation type. And so you might see different people assigning different vegetation types to a given fuel model.
Okay. Because what I do is in this moment I take the only the my English is not so good, so excuse me for that. I try to take in the tip of the vegetation, if the slow, middle, or tree, and do it the same with the vegetation in my area. This is how we beginning to do it. But now you tell me something different. I want to try to make this comparison and see what happened.
Yes, I'd say you could use a similar sort of landscape in the U.S. system to make that comparison between fuel types and vegetation types to see if, in fact, it gives you some insight about the selections you've made and how it's working.
Okay, thank you. I'm going to take the email that we have put in here, and if I do something, I contact with you. Okay.
Sure. I think that Randy would certainly be able to help make contact with me.
Thank you so much.
As both of you have noted, and Zeke, you and I have spoken, the vegetation to the reclassification is the most of, maybe the only subjective step here. And I'm curious as to how, the community has received that, how much participation you got from the community, if they just leaned on you. if there was much discussion about the reclassification. Yeah, how did that go in Alaska?
Yeah, well, kind of as I mentioned with at least the Anchorage area where we do have the hemlock, when people saw that, hemlock was classified as the evergreen, which has a score of 100, the most flammable fuel, they're like, no, no, no. And so we did get pushback on that and did some modifications to that. One of the other things is in Zeke's table, he actually had 2 lines for mixed forest. And with talking with people and just being on the landscape, I've lived in both Fairbanks and in Anchorage. Mixed forests up there have a lot more spruce in them versus around here in Anchorage, it's a lot more deciduous forests. So there's kind of like this decision and discussion to make the mixed forest a little bit less flammable here in the Anchorage area. And so there was some pushback about that. I think at the statewide level, I have to say, I think it was widely accepted, probably because Zeke was on my team. Zeke has more wildfire chops than I do, coming from academia, and has earned the respect from a lot of people here in the state of Alaska, and Michigan. He's been doing this for a long time. So I think that they, when I saw these, they made sense from their perspective, and they also trusted the person who was helping to do the reclassification.
People well before I was doing this work made some strong assumptions that continue to be validated, that the location and predominance of black spruce in the interior drives significant fire growth throughout the interior. The deciduous forests are significant temporary barriers to fire spread, and there's some very well accepted kinds of assumptions and assertions about how vegetation differs in its flammability characteristics.
I think what also really helped is we did, Zeke showed that bar chart, box plot, of showing that areas that burn do have higher exposure values, higher hazardous fuels. We did the same thing with Flam Map with burn probabilities, and there was no relationship at all between burn probabilities and burned versus unburned areas. So I think that also kind of helped, show that this approach, it makes sense.
A student that I'm working with and who Zeke has done some mentoring with sent me exposure risk map for the Central Upper Peninsula that has been super. I mean, it's been illustrative for us already, in terms of teaching the student. And then this will be useful for some county planners in the Central Upper Peninsula. So I'm excited to try this approach for other areas.